So we've seen the Euler method is a simple way to simplify differential equations into a sequence of calculations over time. The Euler method can be applied to systems of differential equations, but there is a caution note. The smaller the step size, the more accurate the estimate to the exact solution, but you can only go so small. You should also have a look at the phase plane plots, and that'll help interpret how two processes interact. 3 processes, 4 processes. There's a whole field of mathematics just to analyse phase plane plots. And you're going to see a bit of that later on. Across Neuromatch, the Euler method is used to estimate differential equations in a number of different Neuromatch days. The linear integrating fire is discussed in more detail and approximated using this method in model types and biological neuron model day as well. Drift diffusion is also estimated using an Euler method for decision making in the systems day. Phase plane plots are discussed in linear systems day and the dynamic network day, and actually were discussed yesterday by Ella when you think about them as discrete algebraic work. And lastly, the Wilson-Caron model is discussed in the dynamic networks day. I've added some bonus materials. The first bit of bonus material is another numerical method to estimate differential equation. It's called the fourth order Runge-Kutta method. I've applied it to the population equation. The fourth order Runge-Kutta method turns up a lot in papers because it's pretty easy to implement, but the accuracy is much better than the Euler method. I've also included just a bit about a recent paper by Dowling and Asenio, where they use a system of differential equations to raise a discussion of how we should define oscillations in neuroscience. A lot of people do experiments on oscillations, but maybe there isn't a strict, clean definition of one. So you can have a look at that, look at the paper, and can interact with their equations that they use to motivate their discussion. Like before, here's some of the reading materials you can look at. The Dan and Abbott book is fabulous for this kind of stuff, and Stephen Strogatz once again to get you a real feeling of phase plane plots. Thank you.